Here's a very short set on the combined gas law. So we've talked about Boyle's law, Charles' law, and Gay-Lussac's law, and the combined gas law combines all of those laws together. So this is the relationship between pressure, volume, and temperature of a gas. So we've got P1 V1 T2 equals P2 V2 T1. So in all reality, between Boyle's, Charles, and Gay-Lussac's, you really only need to remember one variable equation, which is the combined gas law, and then if they don't talk about a variable within the problem, you can just leave it out. So you can just assume that it's held constant. So you don't need to necessarily remember 4 separate math equations. You need to remember the combined gas law equation, and then when you're looking at the problem, if a variable is not talked about, you can just leave it out. You do need to know the relationships, though. You do need to know that Boyle's, Charles, and Gay-Lussac's have different relationships, so you need to know those itself, but the math problem, you can just know P1 V1 T2 equals P2 V2 T1. So let's do a problem. A helium balloon has a volume of 50 liters at 25 degrees Celsius and 1.08 atmospheres. What volume will it have at 10 degrees Celsius and 0.855 atmospheres? So what I want to do is write down my variables first, so I like to just set up a chart like this so that I can write down my variables, much like we've done in the last couple of slides, video notes, and our problems. So my pressure is 1.08 atmospheres, my initial pressure. My initial volume is 50 liters, and my initial temperature is 25 degrees Celsius. My final pressure is 0.855 atmospheres. Now it's really important, sometimes your pressures or your volumes or your temperatures aren't necessarily going to be in the same units. So you need to make sure, one of the reasons why I like to set it up like this is that now I can see, okay, my atmospheres, my pressure is in the same units, it's atmospheres, I'm good to go. If they're not in the same units, then you need to make sure you do a conversion on either one of those two things to make sure that they're in the same units so we can do our division. Our V2 is our variable, and then our T2 is 10 degrees Celsius. Before I move on, I need to remember that with any of these things I need to have temperature in Kelvin. So now I know that T1 is 298 Kelvin, and I know that T2 is 283 Kelvin. So P1 V1 T2 equals P2 V2 T1. Again, watch your 1s and 2s. Okay, write out your variable equation here and then plug in your numbers underneath. So doing this whole thing and then plugging in your numbers underneath, right from here will show I have all of my work. So this is what is being expected of you as a student when you are doing your math. You need to show your work. And then here, just algebraically solve for V2. And then when that happens, V2 ends up being 60 liters. So just the combined gas law, very simple algebra here with what we're doing. Mistakes happen when people don't put their T1 and their T2 on the correct side, when people don't convert to Kelvin, or when units are not the same. So just check those things when you're working through this. And then here's just a combined gas law example in real life. I was going camping and I was making pancakes here. So here's a propane bottle. We were using the propane, so the number of moles was decreasing, thus the volume was decreasing. And if you can see, that's frost around the outside, and it was really sunny. It was relatively warm for being up in the mountains, and so the temperature was obviously going down as well. So all three things were happening there, so just a cool example of the combined gas law. I just thought it was interesting that it was frosting so much, but the sun was shining, it was warm, it was like 70 degrees already in the morning. It was a pretty hot mountain morning. And so the combined gas law in real life, you can see that that temperature is being greatly affected by the volume and the number of moles going down. So there's the combined gas law. Thanks for watching these notes and the Gay-Lussac's notes so that you're ready to do these practice problems in class.